And welcome back. We're picking up with number 3 from the Unit 3 and 4 Midterm Review. So number 3 says, Max and Jillian want to make some money over their school spring break. They ask their parents to let them work around the house to earn money. Their parents agree because Jillian and Max are saving to buy graphing calculators. Dad tells Jillian that he will give her a starting bonus of $10 and then pay $5 an hour for the work she does around the house. Mom offers Max a slightly different deal. She will give him $40 to start, only $30 an hour. So again, let's first look at the question we're being asked, and then we'll come back and look at the key information. So it says write two separate equations, one for Jillian and one for Max, expressing how much money each will earn, including their starting money in terms of time worked. So now, let's start with Jillian. So Jillian gets a starting bonus of $10 and her rate of pay is $5 an hour. So to write a rule for Jill in y equals mx plus b form, that's going to be y equals slope or rate of change, which is $5 an hour, 5x plus the starting value, which is 10. Now let's look at Max. So Max has a slightly different deal. He gets $40 to start. Goodness, it's a lot more. Only $3 an hour. That's way below minimum wage. So let's see what that looks like. Max's equation is going to be y equals 3x plus 40. So now we're asked to graph both of those. Notice the scale on this graph on the y-axis. This axis here where we're looking at amount earned, which of course is measured in dollars. And then we're looking at, on this axis, hours worked. So on the y-axis, or the dependent variable axis, the amount earned, we're using a scale of 5s. So it goes 5, 10, 15, 20, and so on. On the hours axis, we're using a scale of 1. So to graph Jill's linear function, and remember, why are these linear functions? Because the rate of change, or in this case, the rate of pay, is constant. So Jill's starting value is here at 10, so I plot that point. The y-intercept there is 10. Remember, the value of x is 0 at the y-intercept, which is 10. So now her slope is 5. So that's like 5 over 1. So I'm going to go up 5 over 1, 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 and so on. And you guys get the point, I think, up 5 over 1 always, because it's a constant slope. So now I'm going to pause the video and add in the rest of that line that continues that up 5 over 1 pattern. So there you can see Jill's line drawn there. Now let's look at drawing Max's line. So Max's starting value was 40, and his slope is 3, which is like 3 over 1. Now, here's an issue I'm going to write over here on the right side. 3 over 1 isn't really super helpful on our graph because it's hard to see exactly how to go up 3 because of the scale. And I want to be precise. So let's convert 3 over 1 to another fraction that's the same. Like if I multiply the top and the bottom by 10, that's like 30 over 10. So can everyone see that 30 divided by 10 is the same thing as 3 over 1? Because 3 over 1 is 3. 3 divided by 1 is 3. 30 divided by 10 is also 3. So those are equivalent. They mean exactly the same thing mathematically. So instead of going up 3 over 1, I can go up 30 from 40 up to 70 and then over 10. So if I go up 30 over 10, my next point will be right here. And then I'll go up 30 again to 100 and over 10 more. which puts me at this point right here. So now I can connect those 3 points to form the line for max. So there you can see we have the good looking line for max in his graph. So if the graphing calculator costs $72, who will be able to buy the calculator with the least work time? So we just went to all the trouble to make that good looking graph. So let's look at it that way first. $72, that's somewhere around here. So if I draw this line across, it's clear that the green line gets there to 72 at a much earlier time than the blue line. So the green line represents max. So max would get there sooner. And we could say, based on looking at the graph, we saw that. You could also look at it algebraically. So we could look at each equation. So 72 is an amount earned, so it would go into max's rule for y. So it'd be 72 equals 3x plus 40, and we want to solve that rule for x. So if you solve that for x, you should get x equals 72 minus 40 is 32, and 32 divided by 3 won't come out perfectly even, but that is approximately 10.67. So for max, it's 10.67 hours. Now let's look at for Jill. So her rule, y equals 5x plus 10. So 72 equals 5x plus 10. So if you subtract 10 from both sides, that's 62 equals 5x. Divide by 5. 62 divided by 5. That's x equals 12.4 hours. So obviously, that further justifies that max will be able to buy the calculator with the least amount of work time. What if it costs $100? Who will be able to buy one with the least amount of work time? So now we're looking up here at 100, and this time the blue line gets there before the green line. So Jill would be able to buy it faster if it was $100. So if it's a TI-84, Max is going to get it faster because those are a bit cheaper. If it's a TI Inspire, Jill's going to be able to get it faster. So let's look at that algebraically as well. Same process. This time it's 100 that we're trying to figure out what value for x corresponds to a y value of 100. So we plug in 100 for y and we solve. And when you solve that, you'll get x equals 20. Whereas for max, so let's look. This is for Jill. No, that's for max, sorry. So for max, it's 20 hours that it takes, and for Jill, that's going to be 100 equals 5x plus 10. 100 minus 10 is 90. 90 divided by 5, that's x equals 90 divided by 5. My mind is drawing a blank. That's 18 hours. So as we said, Jill is faster there. So challenge question, for what price must the calculator sell in order for Jill and Max to earn the same amount with the same number of hours of work? So the same amount and the same number of hours of work would be the place where these two graphs intersect, and that's right at 15 hours. And it looks like the amount there is $85 if my graph is right. So let's check and see algebraically. So for them to have the same amount, we want to set their two expressions equal to each other. 3x plus 40 equals 5x plus 10, because that represents Max's amount and that represents Jill's amount, and we want to see when those two amounts are equal. So to solve this, subtract 3x from both sides, get 40 equals 2x plus 10, subtract 10 from both sides, get 2x equals 30, and divide by 2 on both sides, so x equals 15. So like I said, 15 hours. Now we could plug into either rule to see how much money that is exactly at 15 hours. 3 times 15 plus 40. For Max, that's 3 times 15 is 45 plus 40 is 85. And for Jill, it should be the same because that was the point of this question, this part of the question. 5 times 15 plus 10. 5 times 15 is 75 plus 10 is 85. So this is, in fact, correct. Now number 4 is a bit shorter. It says the graph shows the relationship between Jessica's distance from a motion detector and time. What is the rate of change from 0.5 to 1 seconds? And is Jessica walking towards the motion detector or away from the motion detector? So remember, rate of change is always the change. Remember this delta, this triangle means change in the dependent divided by change in the independent variables. So in this case, we're looking at distance and time. So that's going to be change in distance over change in time. Remember, another way that we talked about this is change in y over change in x. So this is always y on the graph, the vertical axis, and this is always x on the graph, and that's time. So this way, you can also see it's change in distance over change in time that we're trying to find. Now, it's just two different ways of describing the exact same thing, rate of change. Either way is perfectly valid, and they're all interchangeable. But we have to figure out those values. So it's a rate, which is where the division comes from, of change. And remember, change refers to, we find change between numeric values, we're talking about subtraction. So we want to look at from 0.5 seconds, which is right here, so this point, up to 1 second, which is right here, so this point. So we want to find, first of all, the change in distance. So that change in distance there is 1. And it's 1 what? 1 meter. The change in time from 0.5 up to 1, well, that's 1 minus 0.5, which is 0.5. So 1 meter divided by 0.5 seconds, 1 divided by 0.5 is 2 meters per second. Now, is she walking away from the motion detector or towards it? Well, her distance from the motion detector is increasing the whole time, so she has to be walking away from the motion detector. So it is D. Number 5 is also a good bit shorter. John has $75 in his savings account, and he plans on depositing $35 into the account each month and not taking any money out. Which function rule will give the total amount T that he has in the account after n months? Well, let's think about it. So we've got two numbers, $75 and $35. We want to figure out which one corresponds to the rate of change, since it's a constant rate of change, $35 each month, and which one's the starting value. And I kind of just gave it away. 35 is the rate of change and 75 is the starting value. So the rule would be T equals 35n plus 75. Notice it's y equals mx plus b form, but instead of y and x, we're just using t and n because those are the variables they told us to use. So this one is C. Okay, number 6 says find the slope of a line passing through the points -6, 11 and 2, -9. So remember, slope is just a special name for rate of change when we're talking about a linear function. So it's still change in the change in the dependent divided by change in the independent. Change in the dependent divided by change in the independent. Let's say that one more time. Change in the dependent divided by change in the independent. So in this case, it's change in y over change in x. Remember, these points are always x, comma y, x, comma y. And the little subscript, the 1, represents x from the first point and y from the first point, and the 2 represents x from the second point and y from the second point. So to find the change in y, remember change refers to subtraction with numbers, so we have to do 9 minus 11, that's the change in the y values. Now change in the x values, that's 2 minus -6. So 9 minus 11, that is -2, and 2 minus -6, that's like 2 plus 6, because minus and negative becomes addition. So 2 plus 6 is 8, and now we want to simplify that. That's -1 over 4. So that is the slope of that line. You could also have looked at it on a graph. You could have graphed the points and then found the rise over run, but I won't do that. But you can. Number 7 is a good one. It says the graph shows the distance traveled by two popular motorcycles, the Harley-Davidson and Suzuki. So again, we've got distance traveled on the y-axis and gasoline used on the x. So based on the following statements, based on the graph, which of the following statements is true? So to answer these questions, since we can see they're both about miles per gallon, let's just go ahead and find the slope of each line. So first I'm going to find the slope of the Harley-Davidson. So that's paying attention to the scale. It starts at 4, goes up to 6, so that's a rise of 2. And the run here starts at 5, 6, 7, starts at 8, goes up to 12, so that's a run of 4. So the slope of Harley-Davidson is change in y, vertical change, over change in x, horizontal change. So 2 over 4, which is 1/2. What does that mean for Harley-Davidson? It means they get 1 mile every 2 gallons of gas. That's just terrible. That's going to be really expensive to drive. But let's look now at the Suzuki. Using this point to start and this point, that's a vertical change of 10, horizontal change of 2. So the Suzuki slope is 10 divided by 2, which is 5, which means 5 miles every 1 gallon. So let's look at these statements. The Harley-Davidson gets more miles per gallon than the Suzuki. Harley-Davidson gets 1 mile every 2 gallons, but Suzuki gets 5 miles every 1 gallon, so that's not true. Suzuki is better. The Suzuki gets 1 mile per gallon. We know that's not true. It gets 5 miles per gallon. Harley-Davidson gets 4 miles per gallon. Also not true. So D, the Suzuki gets 5 miles per gallon. That's what we set up here, so it's got to be D. Now this is helpful. Notice both of their starting values were at 0. So when we write the rules, there's not going to be a y-intercept written because it's 0. So for the Suzuki, we said the slope was 5 miles per gallon. So the rule for Suzuki will be y equals 5x plus 0, but we don't need to write the plus 0. So for Harley-Davidson, the rule will be y equals 1/2 x. And again, plus 0, but we don't need to write the plus 0. So y equals 5x for Suzuki, and y equals 1/2 x for Harley Davidson. Let's see if we can find which one that is. Not here, not here, not here. Oh, and it's D again. So this one is also D. Thanks for watching the review video here. So again, the code blank, 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 blank. This third blank is mine. So there's one more video to come. Watch that if you want to get the last blank. Love you guys. Hope you have a great night. And I hope you learn some math.